Welcome. We want to use rules of inference to build valid arguments. An argument is going to look something like this. There will be a sequence of statements, and justifications for those statements are often given. In our presentation here, we will give a justification for them as well. So we have a collection of statements, and we have justifications or reasons for those statements that we can make, just to make it clear as to why we've made these statements. And then, of course, the desire is to use those, these rules of inference that we've previously discussed. Okay, use those rules of inference to draw the desired conclusion, or to conclude that this thing is true. So when I say draw the desired conclusion, I mean state that the desired conclusion is true. So let's take a look at a couple of examples. This first example is purely symbolic. So if I know that P and P implies Q are true, what I would like to do is I would like to conclude that Q is true as well. So what we're doing here is we're using the tautology modus ponens. I know that this is true. Since it's a tautology, when this is true, we must also have that this is true. Therefore, I'm able to conclude that this is true. All right, so I've just said what we're going to do, but what does that actually look like? So here they've called it a step, rather, you might call it a statement. Each of these are statements. And we are assuming that the collection here, or we're working with the fact that all of those are true, and then we want to show or conclude that, or state that the desired conclusion is true as well. So what we have is we have P and P implies Q is true. That is the premise. This is often called an assumption. We'll use that sort of language when we talk about proofs. At this point, I can conclude that P is true, and what I'm using here. So they call it a simplification using 1, but what we're actually using is, I believe, actually is. Oh, I went right past it. Addition. Nope. Here we go. So we're using simplification. There we go. So it is just considered a simplification. Nothing other than that. So what we've specified here, though, is precisely the rules for inference that we are using. So use a rule of inference to conclude that P is true, use a rule of inference to conclude that P implies Q is also true, and once we have that, you'll see here that this is precisely modus ponens, right, that particular rule of inference, allowing us to state that Q is true. Okay. Again, let's go to modus ponens just so we can observe that, right? P and P implies Q allows us to conclude Q. Therefore, I don't know if we said this before, that means therefore. All right. Just about there. Here we are. That was this one, and then the other example that we want to do. There's a little bit more going on, but there's actually it's a contextual thing. We have English sentences that we want to use. So it is not sunny this afternoon, and it's colder than yesterday. We will go swimming only if it is sunny. Now, I don't necessarily like the way that this is written. It's just perfectly valid, but we like to see things in our usual implication or conditional phrasing, if then. So I rephrased it here as if we go swimming, then it is sunny. That is the equivalent, right? These are equivalent. If we do not go swimming, then we will take a canoe trip. Excellent. If we take a canoe trip, then we will be home by sunset. So what we have these statements, and what we would like to do is we would like to conclude that we'll be home by sunset. So I want to take all of these and conclude that we'll be home by sunset. We're going to rewrite this symbolically. This is not what we will usually do in terms of, well, when we begin to write proofs, but it makes sense here, so that way we can use our symbolic rules of inference. So choose propositional variables. It is sunny this afternoon is P. Q, it is colder than yesterday. R, we will go swimming. S, we will take a canoe trip. And T, we will be home by sunset. Sometimes it makes sense for us to use letters that associate to the statements that are being made. In this case, we've not done so. Then our hypotheses, right, the things that we are assuming to be true are that it is not sunny and it is colder than yesterday. If we go swimming, then it is sunny. And here, if we do not go swimming, then we will take a canoe trip. And if we take a canoe trip, then we'll be home by sunset. Excellent. And we want to conclude that we will indeed be home by sunset. So this is our valid argument that we're constructing here. Now we know, right, our assumptions our assumptions are that it is not sunny and it is colder than yesterday. We can use the rule of inference simplification to conclude that it is not sunny, specifically. Excellent. It is also a premise that if we go swimming, then it is sunny. But since I know it's not sunny, then I know that we're not going to go swimming by modus tollens. Excellent. So modus tollens we see here. Now we have another premise. If we do not go swimming, then we will go on a canoe trip. And I know that we're not going to go swimming. Therefore, we're going to go on a canoe trip. So here I see the application of modus ponens. Now, I know that if we go on a canoe trip, then we will be home on time. So here I see another application of modus ponens. So I know that it is that we're going on a canoe trip. Now that if we go on a canoe trip, we're going to be home before sunset. Therefore, I conclude as desired that we will be home before sunset. So that is the construction of the valid argument. I phrased it in terms of the context of the problem because I think that's a little bit easier to understand. However, it's written in this case in those variables. All right, that's all that I wanted for now. So thank you for your time and attention. I'll see you again a little bit later.